So maximum values are values that are looking like they're larger than nearby values, and minimum values are values that look like they are smaller than nearby values. So I think the rough idea of maxes and mins feels pretty good. Okay, so that's just kind of the warm up. You know, if you've watched the video, hopefully that makes sense. So what are the goals for today? We want to work on generating a procedure that we can use to help us find maxes and mins. So from the video, they kind of said that we have a maximum when the function changes from increase to decrease. Okay, and we want to be able to do this looking at a graph, but we also want to be able to do this more analytically using calculus, so we can be more certain that we know exactly what we're doing, and it's not that the graph is misleading us in some way, because we've seen hopefully this semester that you can't always trust graphs. Okay, so a couple questions you might have is, what exactly is a max or a minimum? Where are these things located? How can we find these locations? And can we refine all these definitions and write down a procedure? So that's kind of one of the things we're looking to do today. Okay, so let's throw some definitions at you. F has a local maximum at a point P if f of P is less than or equal to values of F for points near P. So I don't know, maybe you're seeing a theme here of let's take a fairly simple concept and make it really complicated with lots of language. But hopefully by the end of the day, you'll understand why this definition is worded this way. So let me know in the chat window, is P an input value or an output value? Is P going to be an input or an output? Okay. So we need to keep this in mind as we work through these problems. Are we talking about input values or output values? Are we talking about the function or its derivative? And so using the word it is going to lead to a fair amount of confusion. So we want to try to ban the word it from our vocabulary and make sure that we're really cognizant of the words that we're using to help us understand what's going on. Okay, so notice this language here. F has a local minimum at P. And so again, we're thinking about P as an input value. Okay, and then F of P is going to be the output value. And we could say that is the local minimum. So the minimum is F of P, whereas it is at P. So we kind of use the word at to tell us where the thing is located in terms of the input values on the x-axis. Where's this thing at? But the minimum itself is actually referring to an output value. Okay, so let's just jump back here to slide 3. And we would agree that the biggest values would be maximum. So we'd say the maximum in this case is 1. Max is 1, and it happens at x equals -3. So do we kind of see how the difference between like how we're going to deal with inputs and outputs? The maximum is 1, and it happens when x is equal to -3. Do you have any questions for me on that language? And this idea of splitting out the input and the output? So just the idea is that as we're talking about this, be aware of, are you wanting to talk about what the actual extreme value is, what the actual maximum is, or are you talking about where it is located? In this case, different color pen here, look at the origin. The maximum and its location actually are the same, so that's a little dangerous. Here's a minimum. So this case, oh, they're the same as well. Terrible example. Let's not look at that one. This one's harder to read off. Maybe we'll look at this, okay? What is the maximum and where is the maximum? So in the chat window, tell me what the max is. You can say what, and then tell me where. Or you can say there's a max of blank when x equals blank. And in case we can't read, this is a 9 and this is a 1. Okay, so yeah, the maximum is 1 and the where is when x is equal to 9. Or we can say the maximum is f of 9. Another way to maybe think about how we could express what this is. Any questions on the definition for max and min? We'll challenge you in a minute here. Clear screen. Okay. Here's a new graph. Go ahead and label this graph. Again, whatever method you want to use, your maxes and mins, just make sure we can tell them apart. Okay, so here's one student's example. So, question for you all. Maybe we'll take a look here. The max is what, and where is the max happening, or when is the max happening? Okay, so you can let me know in the chat window. Okay, extra challenge. What if I tell you this graph is sine of x? So yeah, we're close enough with those guesses, but if we actually know that this is sine of x, what does this have to be at? When does sine reach its maximum values? Just out of curiosity. Yeah, it's going to be multiples of pi over 2. Okay, so, and the reason I'm bringing this up is I want to nudge you in the direction of being really comfortable with graphs like sine and cosine. So the sooner you can get the unit circle memorized, the better. Okay, that aside, the maximum is 1, and it happens when x is equal to, that should be a minus 3 pi over 2, which is approximately negative 4.5. Okay, it's a little bit farther down than that. Take a look at this spot over here. What is the max and where does it happen? So let's call the first one we did was A. Let's do the second one as B here. So on part B, what is the max and where does it happen? Okay, so the max is 1 and it happens at pi over 2. So when x equals pi over 2. Now, does anything seem weird with A and B? Like, I want a maximum, or do I want the maximum? Are you all okay with this? Does anything jump out at you as a little strange? It shouldn't. I'm just kind of curious to know if anyone's bothered by anything we've talked about so far. Looks like I might be having some internet issues here. If I can get back on. Do maxes and mins always have to be alternating? That is a great question. And so why don't you challenge yourself to draw a graph where the maxes and mins are not alternating? Can we do that on the same page here? I'm going to go ahead and back out of this. Is it possible to draw a graph So if you just want to add a graph to your picture here, can you draw a graph where the maxes and mins do not always alternate? So feel free to see if you can draw a picture where the maxes and mins don't always alternate. So it looks like somebody's taken the bait over here. I like the idea of adding a discontinuity. We may need to be a little more careful about that one. Ooh, I like what Pythagoras did. We're going to come back. We're going to come back and definitely talk about this. So please don't erase your graph. I definitely want to come back and talk about that one. Maxes and mins do not always have to be alternating, but it gets a little tricky talking about them or maybe drawing a graph. So I might have questions for this graph. What is actually going on at the endpoints? That might be my question here. Is the function, does it have an open interval or is it filled in? That might be something to think about. Okay, because if we made all the top ones open, then we would go minimum, minimum, like then it would not be alternating. So that's a really good example. You just might need to clarify open and closed. Okay. So the question is no. I don't know if you have a very good answer as to why, but maxes and mins do not always have to be alternating. So don't get yourself caught in that thing. Okay. All right, we're going to come back to Pythagoras here in just a second. So notice that in these definitions, we say like it's a minimum if the output values are less than or equal to nearby values, or we have a maximum if the output is greater than or equal to. Why do we need this greater than or equal to or less than or equal to? Why do we need equality as part of this definition? Why would we put equality in the definition? Why does that need to be there? And Shu Yuan, we are definitely headed there in just a minute. So if we come back to, let's say this example, okay, how many maximums do we have? So be really, really careful. What is the maximum value? So I'm going to go ahead and label these as A, B, and C. I get my iPad to work. So let's call this A, B, and C. What's the maximum at A? What's the maximum at B? And what's the maximum at C? So how many maximums do we have? How many maximum values do we have? You're telling me one for all of them. So I'm only seeing one maximum. Remember that if I'm asking you what the maximum value is, I'm asking for the output. How many of the outputs on this graph are maximal, are a maximum, are an extreme value? There's only one. How many times does the function attain the max? That's the other question. How many times does, let's call this f of x, reach the maximum value? Yeah. So notice that I said, how many maximums do we have? Everyone answered this question instead. Okay. So there's only one maximum value in this example, one output, one max value, and that is y equals 1. Okay. But we attain it many times. The function reaches its maximum many times, every 2 pi. Okay. Yeah. It's multiples of pi over 2. So pi over 2 plus k pi. Do you see the difference in the language and why it's a little sneaky there? So you want to be careful about that. Now, let's go back to a graph drawn by Pythagoras. Hopefully it's still there. Beautiful. I got some questions for you about this point right here. Is that point a maximum or a minimum? Or what? So while everyone's thinking about that, Nasser, if you have a question. Okay, so some people are saying both, some people are saying neither. So let's maybe go back to the definition. Oh, here's an interesting thing. Is 0 technically positive? So we've got a question here. Is 0 positive? That's a good question. Ooh, I love Cooper's answer. Guess what Cooper did? Cooper went back to the definition. Okay. Cooper went back to the definition, which is great. That's what I want you all to do. Okay, let's just stay right at that point though. Let's not go far away from the point. So everyone make sure you read Cooper's answer in the chat window. Minimum because it is less than and equal to everything around it. So can someone be obnoxious and play the devil's advocate and do the same thing for the maximum definition? And we'll get to critical points in a little bit here. So Cooper says this point is a minimum, but then he cited the definition. Can somebody also do the same thing for supporting why this would be a maximum? Can use the definition. Maximum because it's greater than or equal to than everything around it. Yeah. So because this point, this y value, is both greater than or equal to all the nearby points and less than or equal to all the nearby points, it is both a maximum and a minimum. Okay, so I don't know if this is probably 2. So we'd say that all of these points on this horizontal stretch are both maximum values and minimum values because those y values are greater than and equal to all the points around it and smaller than or equal to all the points around it. Hopefully it feels a little weird, but hopefully you can kind of reason your way to where you can accept that. Yeah, Cooper, what is your question?
So what's it mean by nearby points? Because like on the graph, it kind of looks like it's in like like it's in the bottom of like a hole, sort of. So like, would we only go like 1 or 2 past that point, or would we look at it more at a bigger scale?
So that's a great question. What do we mean by nearby? And another word that mathematicians will use is locally, and it's kind of vague. But what we might say is like, we need to at least include a few other points around it. And then this is where you get into the number line, which gets a little weird, like, can you go just one point on either side? Because if you go a point, there's a distance between them. And if it's the real number line, those are filled in. So no matter how tightly you make a little window around your point, you always have an infinite number of points. So this gets a little deep. But as long as you can make an interval around the point, we want to consider everything in there. So maybe you have a graph that does this. And when you zoom in on this part, it's actually flat for a good stretch. So you'd have multiple points that are maxes and mins. So yeah, it's a little weird to think about what does nearby mean.
So like, to follow up, I guess. So like on that one you just drew, it like looks like a maximum, but there's a small point where it would be flat. So you could still technically justify it to be a minimum?
I would say that, yeah, all of these points that are circled are both maxes and mins. So this also reinforces the idea that a graph is not the be all end all answer. It doesn't, we can easily misinterpret a graph. So Jace is saying it's relative to the interval. Yeah, it is totally relative to the interval. Because what if I said, I like this graph, but I'm going to ignore everything except this bit right here. Now where are the max and min values? So ignore everything but the part that's circled in red. So then the minimum, the new minimum would have to be here, and the maximum would be there. Yeah. So if the intervals change, your maxes and mins can change. Okay, so let's get to this question. Is 0 positive? So locally, just to reiterate, locally just means you're standing at your point and you go a little bit to either side. And I know a little bit is vague because even if you go the tiniest little bit, you always have an infinite number of points there. But as long as you can make some wiggle room, okay, this idea of wiggle room is a pretty big concept in analysis, which is a fancy word for what calculus basically turns into. As long as you can make a little bit of wiggle room. And what I'm doing with my hands is drawing those parentheses, the open parentheses here. That's what we mean by locally, nearby, okay? You're not just looking at a single point, you're looking at the points nearby. And that's been a theme with this class, right? When we do limits, we're looking at the nearby values. Okay, so that's what I mean by that. Now, is 0 positive? Let me know what you think in the chat window. Is 0 positive? And I don't know is a great answer. So please understand that I'm perfectly happy with you saying, not sure. Not sure, don't know, both, neither. Okay, so we're going to say no. We're going to kind of go with a convention that says 0 is not positive. So if we're looking at the number line, anything bigger than 0, so this is like the X number line. Anything bigger than 0 is considered positive. Anything less than 0 is considered negative. And 0 is neither. 0 is neither positive nor negative. And this idea is actually, this is a really important thing that we're going to be talking about today as well. Okay, so we're going to adopt the convention for the rest of this course. And I would say most of your math classes from here on out, that positive numbers are numbers greater than 0. So we might maybe formalize this. If x is greater than 0, x is positive. If x is less than 0, x is negative. If a number is less than 0, that number is negative. And 0 is neither positive nor negative. Okay, so yeah, it's great to ask these questions because I've been involved in the math world for so long that these conventions are just like things that I just eat, sleep, and breathe, and I don't think about it. So when you're new to the world, you need to explore these ideas. So thank you very much for asking that question. Okay. All right, so do we have a better understanding about the definition of maximum and minimum, why it includes equality, what it means to be local or nearby? Scrolling through the chat window here to make sure I have all the questions. How hard it is to talk, like it's easy to slip up and ask, like talk about the maximum as an X value versus the Y value. So making sure we're cognizant of that and paying attention to how we're talking about this. Yes, Nasser, what is your question?
Is it possible that we can have mini maximum or mini minimum at the same input?
So, okay, is it possible to have mini maxes and mini mins at the same input?
Yeah.
So would that mean you would have multiple output values at that same input?
Yes. Like if there's like a jump or something.
Okay, I'm going to clear this screen. So if you need a copy of anything I've drawn, please take a screenshot. So if we have a graph at a certain X value, let's call this X equals A. If you're going to have multiple X values there, multiple defined pieces, then we don't pass the vertical line test and we won't have a function. So for the purposes of this class, we're restricting our discussion of maxes and mins to functions, so to things that pass the vertical line test. There might be a branch of mathematics where this might be a question you would want to ask. Okay, so the best we would probably have would actually be open circles. Like we could actually do open circles, but we actually only have one y value for the given input. So this would be f of a. So to have a function, we can't have more than one y value at a given input, which is going to limit us to having only a maximum, a minimum, or neither for a given input. But this graph might be interesting. Is f of a max, a min, or neither? Let me know in the chat window. And Nasser, if that didn't address your question, you can go ahead and elaborate further if you want. But in this graph that I just drew, f of a, max, min, neither. Or I don't know. You can always put, I don't know. There are nearby points. You want to be a little careful about the nearby points idea. So if I'm going to go to the x-axis, I'm going to, we could draw a little tiny interval of nearby points, but let's make it big enough we can actually see what's going on. Just pretend we zoom in. So nearby points, if we're on the left side, then we're down here. And so our point in question is actually bigger than those points. But if we're on the right side, we're up here. So our function value is smaller. So our function value is not always bigger than or equal to all nearby points or smaller than or equal to all nearby points. So I think going back to this idea of nearby, nearby has to mean both sides. Nearby means both sides unless otherwise specified. The fancy language for this is what a mathematician would call an open interval. And it's the idea of wiggle room. So if you're standing on part A and you get like jostled one way or the other, kind of include all of those points, the output values get sent to outputs that are both bigger than or greater than. So f of a is neither a max nor a min. Okay, it's not a maximum because there are values that are larger than it. See the green points. It's not a minimum because there are nearby values that are smaller. See the blue points. Okay, so how many people thought we'd have this much to talk about when we introduced maxes and mins? Okay, let's do this again. When x is equal to a, do we have a maximum, minimum, neither? If there's a max or a min, tell me what it is. So if you think there's a maximum at C, type max C in the chat window. If you think there's neither, type neither or n. If you think there's a minimum, let me know. Or both, or I don't know. So I've got a bunch of n's. I have a both, I have a min, a couple mins. Okay, so let's do that nearby thing again. So if we are near A, but on the left side, the values are up there. If we're near A, but on the right side, the values end up there. So can we say f of A is greater than all nearby values? Can we say f of A is smaller than all nearby values? So f of A, which is equal to B, right? That's where the thing is defined, is less than or equal to f of x for x near A. How do you feel about that statement? Okay, so that would be a way of using the definition. There's a good testing of standard T1. That's a good way of using the definition to show that f of a is a minimum. Okay, let's tweak this graph slightly. Okay, new graph. Is f of a, or no, let me rephrase this. Does this graph have a maximum? And if it does have a maximum, tell me what the maximum is as best as you can. If it doesn't have a maximum, tell me why not. So the question is does this graph have a maximum? Is there a max? If so, tell me what it is. If not, tell me why not. And to be painfully clear, just to make sure, have I actually defined f of a? There's an open circle, so I have not defined. In fact, we could even make it more painfully obvious. What if I do this? What if I actually, let's put f of a where b is. Okay, so now f of a exists. Does this graph have a maximum? So some people are saying no, some people are saying there's a minimum. Some people are saying it's near where that hole is at C, but not quite there. Some people are saying B is the max. Okay, let's start with the nearby thing. So we already did the blue bits. If X is close to A on the left side, the output values are close to C on the left. If X is close to A on the right side, the outputs are close to. So those output values are all bigger than f of B. So that might indicate that f of B is a minimum. What I want to talk about, is there a maximum? And let's make this game a little more exciting. Instead of having C there, let's give it a number. Let's say that this is the number 4. Is 4 a max? Aren't there maxes on either side of the hole? Okay, so it's a good question, Jewel. Okay, so we don't like this. We don't think 4 is the max. So the question is then, what is the max? So Jules has a suggestion. Okay, so I want you to tell me the number. If you think there's a maximum there, what is the number? The maximum has to be a number you can tell me that is bigger than or equal to all the values nearby. Okay, so you see this isn't a super easy question. Could it be the limit? Okay, here we go. I love this. I love this. We got 3.9. Then Nasser's like, I can do better than Myron. I did 3.999. And Samantha's like, oh, well, I can do better than Nasser. And she did 3.999999999. Can somebody do better than Samantha? Can somebody find a bigger output value? Does Samantha have the max, or is there a bigger one? Is there a bigger? Oh, Hussein, give me one answer, just one number, not a range. Give me one number. If there's a maximum, it is one number that is bigger than all of the nearby outputs. So far, Samantha's winning. Can somebody top Samantha's suggestion for a maximum? Okay, but 4, it doesn't actually exist. There's a hole at 4. We don't have a function value at 4. Oh, Colin, yes, I love it. Colin beat Samantha by quite a bit. Can somebody beat Colin? Oh, Colin, you did it. Sorry, you said a direct message. I'm gonna resend it to everybody. A student sent this. Except that I can't apparently cut and paste. Can somebody beat that answer? So 4 doesn't work because the function doesn't reach 4. There's no value there. There's no input that gives us 4 as an output. And remember, the max is the f of x, the f of p value. So this is what we're asking for. Is there an f of p? Okay. So there you go, Nasser. Now some people are getting it. You get the hang of it. We just need a bunch of 9s. Okay, so Jace is going into here with the 3.9 repeated forever. All right, everyone, what is 3.9 repeated forever? Maybe I shouldn't have opened this can of worms. 3.9 repeated forever is exactly 4. So we can't use 3.9 repeated forever. So Nicholas, so far you've got the win, but in theory, could somebody beat Nicholas? You just have to cut and paste what Nicholas did and add one more 9. And that process will never, ever, ever stop. Okay, so let's make sure we understand. There is no x value that spits out 4 as an output. Okay, so we can't use 4 as a max. No x gives us f of x equals 4. Okay, so we can't use 4 as a max. But anytime we try to pick a number that's close by, like 3.9, somebody can do better by picking 3.99. And somebody can do better by picking more 9s. Okay, but we can't pick an infinite number of 9s because that's the same thing as 4. So there's no way to win this battle. And therefore, an example like this is no maximum. An open, like a function going up to an open hole, no maximum. That's the conclusion there. Questions, thoughts? Four is not the maximum because the function's not defined. Now, if I had moved this point up and filled in the hole, then we could do that. But there's no, that's not the situation that we have here. I don't know what that emoticon is for your mind's blown.
I have a question.
Yeah.
How can I ask? Does the function have a local maximum or local minimum if it is defined or undefined on that exact input? Like if it is undefined, does it consider as there is like no maximum at that point, or it has to be defined?
So remember that extreme values, maxes and mins, they're actual output values. And so if there's a hole in your graph, there's no output value there to answer the question. The answer to a max or min needs to be an output value. So if you have a hole in the graph, there's like you're going to pick up the maximum, but there's nothing there to grab because there's a hole in there.
Okay, but why the definition of the maximum minimum does not specific does it say that? Why it doesn't say that it should be defined, or is that just like something that it has to be?
Okay, hold your question for 1 second. I'm going to answer somebody else's question so I can use this page. Then I'll clear page and we'll go to the definition to investigate that. So somebody's coming back to the idea. Somebody brought up a limit. Does that change anything? So the best we can do is say that, yeah, the limit as x approaches a of this function is 4. So if the function were filled in, 4 would be a logical max. 4 is also a logical upper bound. Like we don't think this function is going to get above 4. So 4 is a logical conclusion for an upper bound of the function. But there's still f of a does not equal 4. So 4 cannot be a maximum. Okay, so the limit helps us understand what the function is doing. The nearby values are tending toward 4, but we can't say that 4 is a maximum because there's no actual function there. And so to get more information on that, let's go ahead and head over to the definition slide. See if I can remember where that slide is at. So Nasser is complaining, and I'm not saying that in a bad way, you're raising a good criticism, that why did my, there we go. Okay, sorry, I had a lag on the internet. How are we already out of time? Sorry for going late. Nasser's raising a criticism that like maybe we should add something to this. Okay, so f has a local minimum if f of p is, let's put this here, local minimum of p if f of p is defined. And so you could add that in, but you could also argue that if there's no f of p to be less than or equal to, then it doesn't exist. But yeah, we could definitely add that. You need to have the function to be defined to have a max or a min. So that's a great addition there. We could definitely add that in. Okay. Hopefully you all have a better feel about what makes a max or a min. And the next thing to really start focusing on is this idea of how can we talk about translating where the function goes from increase to decrease. Yeah, it's exactly this. We want to look at where the derivative changes from positive to negative or vice versa. So please work through the rest of the Desmos activity as best you can for the participation points for today. So participation equals Desmos, okay?